Okay, here I am for part B. So let's reread the problem statement. For the state of stress shown, determine the maximum shearing stress when sigma y is equal to 20 megapascals and when sigma y is equal to 140. And this is the case we're doing now because we already did A. Okay, so we already found that for sigma y, we're going to have 140 and 140 on both the x face and the y face. The shear is positive on the x face and negative on the y face. So that implies that we're going to plot it in a different quadrant. So that because the sign does not have a physical meaning for shear for isotropic materials. So let's see, we have 140 and 80. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 80. 1, 2, 3, 4, 5, 6, 7, 8. So notice how I'm plotting it below the sigma axis. And that's going to be my x face at 140, 60. My y face is going to be at 140, negative 80. So at 140, negative 80, that's going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right here. So my y is 140, negative 80. So now we can connect the two. They should be perfect. Hold on. It should be 1, 2, 3, 4, 5, 6, 7, 8. And they should be perfectly straight. So let's fix that. So like here. But remember, this is not the radius. This should be the diameter. So let's make a circle here. And let's just try to keep it at the center right here. So let's expand this. Let's actually expand this all the way down to here, right? Okay, so we expanded to here. Now what are we going to do? Well, we're going to look at a couple things. We're going to find what is our center. So let me write right here, center. Well, that's going to be the average between 140 and 140, which is 140 and 0. So it's going to be right here at 140, 0. And so what other information do we have for this? Well, we know the radius is 80, and we're trying to find the maximum shearing stress. So here the maximum shearing stress is 80. However, we have a sigma z here, which is equal to 0. And we're also saying the tau on the z face in the y direction is equal to tau on the z face in the x direction, and it's equal to 0, which means that that's a principal stress as well, which means that we're going to have a point here as well. And what does that mean? Are we going to connect? This is the question I have for you. Are we going to connect these two together or these two together? Well, we're going to connect both. So the small one here is going to look like this. And then I'm going to take it and center it right here. And then we're going to have the one connecting. This is sigma z. So this is the z face. This would be I'm not sure how to do all of this. So here we're going to get this, and we're going to put it here. So we notice that the bigger circle is going to be the one with the highest shear, which is going to be kind of here. And it's going to be what? Well, it's going to be sigma max, which is right here. So sigma max is going to be 140 plus 80, which is equal to 220 megapascals. And so now we're going to say that at 220, the center of the big circle is going to be 220 divided by 2 is going to be at 110 comma 0. Now, why is that useful? Well, because we know now that the radius is 110. And so 110 is the largest shear. So tau max, not in plane, is 110 megapascals. Conceptually, I'm still a little bit shaky on it, but I feel like this is a good start. So you see how the in-plane shear stress is the 80, but the overall absolute max shear stress is the 110, if you consider the planar stress situation that we have in this case. And one thing that's a little bit confusing still is, what is this point? Why do we decide that this is where Z, the small circle is, and this is where the big circle is? I still need to get to that.